So now that I have my solid, I'm now going to make my 100 ml of roughly 0.01 molar solution. Now, before I continue, I want to introduce some key glasswares for measuring volume first. Here I have a volumetric flask. Here it is up close. So there is only one mark, can you see it? There is only one mark on the volumetric flask. If we fill this with liquid, and the meniscus would reach this mark, then we could say that we accurately have 100 ml of liquid. If you could also see, it says here it's TC. Can you see it? TC. TC means to contain. That means if we measured up to the mark, it will contain 100 ml. A pipette will allow you to accurately transfer volumes from one place to another. So for this pipette, notice that it says 10 ml and it also says TD instead of TC. Again, TC stands for to contain. A pipette is TD, which means to deliver. That means if you start at 0 and then finish this up to 10 ml, that means you delivered 10 ml. I have here a 10 ml volumetric pipette. So the volumetric pipette has one line, and this is 10 ml. Again, it's still TD. So when you fill this up to the mark and you allow it to drain, you are delivering 10 ml, but inside it's not necessarily 10 ml. It's calibrated to deliver and not contain. Now, I'm ready to show you how I'm going to make the 100 milliliters of solution. So all of my glasswares here are clean. They've been washed with soap and water, and they've also been rinsed with distilled water and dried. So what is the first step? This is a wash bottle. I'm going to add just a little amount of water to dissolve the solid. It's much smarter to dissolve the solid before you even transfer it to the volumetric flask. I have here a clean glass rod, and I am just mixing the solid to make sure that it's fully dissolved. The next step is to transfer the liquid into the volumetric flask. I'm going to use a funnel. Let me place the funnel inside, be careful. And I will just directly pour it in. I've already transferred most of the chemical inside the volumetric flask, but we want to be exact, right? There are still some droplets inside of this container. So what I'm going to do is I'm going to rinse the container and add the liquid into the volumetric flask. So I'm taking my wash bottle, I'm rinsing the sides of the container, mixing it up, transferring. Rinsing it second time, shake, shake, transfer. Third time, shake, shake, transfer. All of the glucose inside the beaker should have already been transferred inside the volumetric flask. If you noticed, however, I never put down the glass rod because I also need to rinse it 3 times. First pass, second pass, third pass. I'm now done with my stirring rod, so I could put it down. There's no more glucose on the rod. Lastly, I need to rinse the funnel itself. First pass, second pass, third pass. What I need to do now is to dilute this to the mark. Again, after I dilute it to the mark and mix it, it should be 100 ml because this is a to contain glassware. This is distilled water. I'm going to transfer into my small beaker. I will use the small beaker to add liquid into my volumetric flask. Now, some people would like to use a wash bottle instead. That's totally fine. Make sure you're reading or looking at the meniscus at the eye level. This volumetric flask doesn't have a cap, so I'm going to use parafilm instead. Parafilm is an inert type of material that we use to seal stuff. I'll just get a small amount. So this is the amount of parafilm that I will be using to cover my volumetric flask. I don't need a lot because To use parafilm, you stretch it both directions, x-axis, y-axis, and now you have a material that has the consistency of something like cling wrap. I apply the stretched out parafilm onto the mouth of the volumetric flask. I seal it. Now it's completely sealed. To mix it, I need to invert this around 36 times. So to invert this, I hold the base with my left hand and the top with my right hand, and then I invert. If you did your parafilm correctly, nothing should come out. I shake it, and then I return. That's one time. I need to do this 35 more times. I now have my 100 ml of solution. If you diluted it incorrectly, like if you passed the line, so the meniscus is above the line, that's already gone. It's not exact anymore. We want to be exact again. We want to be certain. So if you missed the mark by adding too much solvent, you need to start over. That's just how analytical chemistry works. Because I accurately know the mass that I used to create the solution, I could now calculate for the new concentration, again with the fixed value of 100 milliliters of solution. Now, let's do something else. What if I took 10 ml of this solution and diluted that to 100 ml in another volumetric flask? Let me show you how to do that. I'm going to transfer the contents first to another container before I start measuring my 10 ml. Since I'm dealing with volumes once again, I add a little and then I rinse it 3 times. Make sure that you wet all the sides. That allows all the dirt and other chemicals to be washed away by the liquid that you're rinsing it with. And then I throw it out. That's first pass. I need to do this 2 more times. Because I've now rinsed this, I can now confidently put in my solution. I don't need a lot. A volumetric pipette is more accurate than an ordinary pipette. So I'm going to use a volumetric pipette. The thing about pipettes, however, is that you also need to rinse inside the pipette. So how do we do that? Get a little. This is an aspirator or a bulb. It will allow you to suck up liquid into the pipette. And I've capped, using my finger, the tip of the pipette so that whatever I took out will remain inside the pipette. I have a little liquid inside. I'm just gonna do the same thing. Allow it to touch all of the sides of the pipette, and then drain it out. 2 more times. And that should be it. I will now show you how to get 10 ml, so I'm going to transfer up close. I have here the solution, and again, I'm going to take out 10 ml using a pipette. So to do that, I'm going to take my pipette. I'm going to make sure that it's completely vertical, and then I'm going to submerge it. I'm going to make sure that the tip of the pipette is not touching the base of the container. So in this case, to allow it to suck up the liquid better, I'm going to make sure that there's some space between the tip of the pipette and the base of the container. I use my aspirator or my bulb, and then I draw up liquid. I need to get liquid beyond the mark. So, as you can see, the meniscus is well above the mark. I'm now going to roll my finger covering the pipette. I'm going to do this motion. If I do that motion, the meniscus will slowly drop. The meniscus is exactly on the line. All right? Some students, they use a pipette and then they lift their fingers. That's gonna drop a lot of liquid. Again, you need to roll your fingers above the tip of the pipette. So let me do that again. I'm lifting the pipette to meet my eye level. I'm using my other finger in my other hand to make sure that it's vertical so it won't budge, and then I roll my finger. And that should be it. Now, I'm going to transfer it to another volumetric flask. So pipette inside volumetric flask, again, this is clean. And then I allow it to drain completely. Just let it drain on its own. Some people like to use the aspirator to push out the liquid. I don't recommend that. It might affect your results. Everything's drained. What I like to do is I like to roll the tip of the pipette inside the walls of the container. That way, any residual liquid will be transferred. I put it down, and then I dilute once more. 36 times. What might be the concentration of the liquid inside this volumetric flask? Make sure to have a pen and paper nearby and really think about what happened between these two videos to ensure that you truly understood what happened in the laboratory. This has been Sir Le. I hope you learned something from my short trip to the research laboratory, and I will be seeing you soon. We will be talking more about errors in analytical chemistry as well as some fundamental calculations in analytical chemistry. Bye-bye!